Thank you all very much. The intention is to talk about what AI implementation looks like for an operator, because this is not something that is conceptual for us. This is something that we are actually applying in theater right now. We have computer vision algorithms that help us with targeting. We have anomalous behavior detection algorithms that are helping us find which points of interest out of a pattern of life are more or less threatening. This, again, is not concept. This is reality for us. I think that there are a couple, what we have learned really during our commands experimentation that we'll go into in a little bit more detail is that the friction points for adoption are often very, very different for the friction points that we talk about from a conceptual level for what makes it difficult. So if you think about data being the limiting factor for maturity and function of a model, we at the edge have found that network infrastructure and function is a limiting factor for adoption and use of anything. We have found incredible examples of models that have exquisite capabilities, but we can't use them where we're at because there is not the compute power available, because the interface or the type of software is not available, because it doesn't run on the right classification of network. And so there are all these friction points that are at an underlying layer. And so I would offer that as we talk a little bit more about what we're doing at the command, we think about that in that framing. If you think about a model as an exquisite capability, I think that it's important to remember that it is an end state that is enabled by all of these different investments and activities before it. In the same way, if you had an F-22 that just appeared in this room right now, the potential for capability and impact in an operational space would be incredibly high, but the practical implications and impact on capability would be zero, unless you built out a runway, unless you built out the fuel reserves and the supporting capacity in order to enable that end state of what is going to actually deliver some sort of effect. In the same way for us, if you don't make those initial investments, if you don't think about the underlying infrastructure and what you need to have, what the personnel you need to have in place, the training you need to have in place, and cater it to that particular model, to that algorithm that you're looking to deploy, from an operational standpoint, you will have a very difficult time. So we're going to get into some of the details of what we're thinking about here. So when we talk about AI, for us, it is useful to break it out into the different components of, this is not just a conceptual AI in operations. These are very specific technologies and activities that you can do to ensure that AI is actually allowing you. So you start actually with collection, because we talk about this all the time. Data is really the fuel that allows these models to perform in a meaningful way. But in a lot of the areas that we operate, you don't even have the data collect to then fuel a model. Task Force 5.9 and the folks there will be coming up later today to talk about some of the experiences that they had. But a huge problem is not, I have the data and I want to do something useful with it. It's, I don't have coverage in the area on, below, above the sea to actually even know what's happening at all. So the first step is to get that data collection at all. And then the second is, okay, once I've collected all of this data, too much data can be the same as no data if I don't have a meaningful way of analyzing it, and particularly at speed. Because again, for our purposes, just sort of recurring analysis without a particular deadline is not the name of the game. We need to be able to identify points of interest very quickly if we're going to take action on them in a meaningful way. So again, timeline, deadline-bounded analytics is really the name of the game once we've actually collected the data. The sharing, this is to the network infrastructure piece of this. I will hammer on this again and again. This is the make or break of whether or not models have any impact on our operations. We have had some really interesting, sometimes depressing, occasionally uplifting conversations with the services about the network infrastructure that we rely on, both here in the States and especially overseas, and the limitations and options that we have out there in terms of capacity. Because if you think about it, again, from start to finish, if I've collected data at a certain point, and then I need to push it back to a home base where you can run analytics, and that pipe is severed, suddenly everything downstream of that stops. Or if you collected data and then you get it to your home base where you can conduct analytics, but then suddenly the analytics can't be pushed back to a headquarters that has to make a particular decision about how you act on something, again, your downstream has been cut off. And so the network infrastructure is the make or break as to whether or not you can operationalize anything related to anything that we've spoken about today. And then finally, execute, where I think sometimes we think about AI and machine learning purely from an analytics, a passive perspective, but for a combatant command like ours, this is very much, we have to act on this. And so building the tools into the same interfaces that are collecting and analyzing these data flows is so important, because the point is that that should be seamless. It should not be that the analytics is happening here and then you have to pivot to another work tool that allows you to say target or to take some sort of effect. And so for that reason, increasingly, the distinction that we've previously drawn between the J2 intelligence shop and the J2 operational shop is blurring because the two need to be looking at the same picture. And given the speed of what analytics can provide us, it is so, so important that they are on the same page. So getting into a little bit more specifics about the data collection. So again, the idea that we simply have the data we need and that the department is ready to go is sadly not true. Both the air and the maritime space are really good examples of this. We as a combatant command certainly have very particular gaps related to assets being moved to other regions. We appreciate and are fully supportive of strategic competition and the need to move assets to other regions. That doesn't mean that we still don't have a job to do here. And so what that means is that the assets that you previously had to put up in the air, to put out on the water, are diminished. And so it's like turning the lights off in a room, where your ability to see the geography, the water around the Arabian Peninsula, the air above the Arabian Peninsula is suddenly significantly diminished. And so that's why we started looking at some of these other alternative, like unmanned systems, to start collecting more data. The idea that it is unmanned happens to be one of the conveniences of the fact that they are able to stay out for 200+ days for all of the benefits that we've seen. But the reality is that orienting yourself around the problem and not the technology, I think, is an important way of thinking about this for adoption, because the point is not to buy an unmanned system for the sake of having an unmanned system. The point is that I need persistent ISR out in a particular area. I don't want an algorithm because it's fun to have an algorithm. I need an algorithm because I need to be able to make a decision faster and I don't have a lot of time and I have too much data to sift through. So orienting yourself around the problem, thinking of technology as the enabler rather than the end state is an important piece of how we think about this. In the airspace, of course, it's the same issue. You only have so many traditional assets to put up in the air. And so if you can augment those, whether it's with long endurance UAS, whether it's with high altitude balloons, all of these, the point is to collect and suck up the data that allows you to do any of the fun modeling and analytics that we're talking about down the road. This is 90% a collect and sort your data and organize it into a place where you can then use the models, because otherwise you just have an F-22 sitting in an empty room if you haven't made those investments in everything before it that actually allows it to function. So then when you go into the data analytics, I'll go in a little bit into a couple of examples both in the maritime and the airspace. I'm going to try my best not to steal all of Task Force 59's thunder. But the idea is that you're starting in a place of, okay, I have more eyes out. I've collected more data. But this is meaningless. If I'm an analyst and I'm trying to find a vessel that's smuggling weapons to the Houthis, this is too much. I cannot, as a single analyst, manage that. And so how do you start digging into that and understanding how you can do it better? And this is where we found that machine learning can be really interesting. From a computer vision standpoint, it's like if somebody handed you 2,000 photographs and said, find me the one vessel in this stack of photographs that is a dhow that's carrying something that's not fish, and it's in the weird part of the region. And computer vision can help you with that by sifting those photographs into buckets and saying, these are commercial tankers, don't need to worry about those. These are military vessels that happen to be in a place where they should be. This stack of photos appears to actually be a little bit strange. And so what we found was that an activity that used to take an analyst, say, 8 hours to get through all of the imagery in the feeds could drop to 45 minutes. That is extremely meaningful for us. 7 hours and 15 minutes of an analyst's brain back to work on something else is extremely, extremely meaningful. And I think that really a key point here is we're learning that in an operational context, I think maybe we misunderstood the way that algorithms were going to be applied. I think sometimes we assume that algorithms are going to hand us the answer, and the reality is that they are very good at pointing us in the right direction. And if we accept that that's the point and that that's enough, we actually will be able to adopt much faster, because the angst and the friction comes when you assume that something is just making the decision for you, that something is looking at the ocean and saying, I identified that that is a point of interest that is now a high threat target, and I will act on that. That's a really high-risk scenario, especially if you're not sure about the data that you fed the model, if it can't explain itself afterwards. But if instead of doing that, it can shave 30% off of a human operator, that's enough for us. We can work with that. In the same way for ChatGPT, we have really interesting conversations with folks about, what would ChatGPT ever write a president's daily brief or any of these critical documents? And to us, that's not the point. The point is not that it is going to hand you the answer. The point is that it could write you the first outline that would save you 40% of your time. and that your human brain could then use for something else. So from an operational standpoint, frankly, we may be more risk averse for that exquisite end state that we talk about algorithms in, of it's going to suddenly create the decision and execute on the decision. But we think that we'll get value earlier because we accept that time saving alone is an acceptable value add from an algorithm. It does not have to create the perfect answer in the most beautiful document. It can save you 30% of your time, and that is sufficient. So it's not only the maritime space. You could take this picture and then elevate it up the ground, and we have exactly the same problem. In the last year alone, we had just shy of 100 one-way UAS attacks and rocket attacks in Central Command. I think sometimes it's easy for folks not at Central Command to forget that we have been in combat operations for 30 years, that we continue to be an extremely active zone, that the one-way UAS attacks that you hear about in Ukraine, those are Iranian drones that have been shipped out to Russia. We face the exact same thing in our theater. And so it's extremely meaningful to be able to understand the pattern of life that's happening in the air around you and understand when something is coming from a particular heading at a particular speed and appears to be a particular size, to be able to identify that very quickly so that you can respond. I think you can imagine how that creates meaning. And so all of those are the ways that for us, collecting the data first and then being able to analyze and understand the patterns of life so that you can see when something falls out of it becomes really important. Finally, data sharing. I know that talking about network infrastructure is not the most shiny or fun or sexy part of AI and machine learning, but I will never get off this soapbox. This is what allows us to do this at all. Because when you think about, let's take the example that I just talked about of counter UAS. If I have the data collection from my airspace, and then I have my algorithm that runs perhaps elsewhere because the compute power wasn't available exactly at the location where the base is located, and then none of that information is able to be pushed back to headquarters, where we might be able to assist or give guidance or deconflict because we know something else is happening, then again, all of this is for nothing. The network infrastructure and your ability to push data to the place it needs to be, fuse it with the other data streams that are required to run the analytics, have the compute for algorithm to run and perform any sort of meaningful insights, and then respond to it is really, really what enables any of this. So algorithms on their own are increasingly less interesting on it to us. The question is, do they run on the network with the right classification of other data that we need? Do they run in a particular area at a forward operating base or on a vessel where the bandwidth is, in technical terms, real bad? These are the types of questions that we really have to deal with increasingly, and so for us, network infrastructure is at the core of anything related to AI adoption. If you haven't thought about who your user is and where they're sitting and how they're going to actually use your algorithm, you may be missing the mark, and you may get down the road and discover that it is not practically feasible to adopt what you're building. And then finally, execution. So for us, again, the algorithms are a fascinating and augmenting capability that have to be integrated into a much broader workflow. So the example that we have up here is what we call our targeting workbench. And what you can imagine this previous process looked like was someone puts in the information around a point of interest into a PowerPoint, and somebody else does the same thing into another PowerPoint, and they get on the phone and they deconflict the things that they put into their PowerPoint, and then they PDF it, and then they send it to their leader, and at that point it's taken 3 hours, so it's actually out of date, so you have to go redo that entire process. And again, the reality is that what actually makes any of this effective is if the insights from an algorithm can then be fed into a digitized workflow that allow you all to see the same picture and respond to it at a speed that is relevant. And so algorithms on their own are interesting, but algorithms that are integrated into a broader workflow that allow you to respond and act to it across an entire headquarters, and truly, eventually, for certain situations, up to the joint staff level, up to the Secretary of Defense, is what allows any of this to be meaningful. Because sometimes we have conversations about teams that are developing algorithms, and they talk about the exquisite computer vision capabilities they have, and they talk about the exquisite models that they're building, and then we ask them, that's incredible. How quickly could you push that image? How quickly could you push that insight to an operating center out in theater? And they say, oh, we'd have to get a data sharing agreement in place, and that would be difficult. And then we'd have to get past the API. We'd have to build an API, and then we'd have to pass the API keys. So probably a couple of months. That answer just isn't sufficient. And so again, thinking about these algorithms in the context of what is the point? We are not doing analytics for the sake of analytics. We're a warfighting organization. What is the effect that you would like to have on the back end? And do you have the data sharing and the network infrastructure in place to allow an appropriate response to happen afterwards? So that is an important piece of what we are trying to get at CENTCOM. So this is really digging into, again, take a deep breath. I swear that this is going to be fun. This is really getting to the core of how we as a combatant command think about our problem set. I wish that our problems were exquisite algorithm performance and whether or not our models were performing in the ways we wanted. The reality is that we are simpler animals than this. Our problems are more pedestrian. We have choke point issues where we are using extremely manual, risk-laden methods of input, where we are wasting people's time on things that could be automated. It is not that we need to reform the targeting process or try to change doctrine. It's simply that we need people to not be manually putting the exact same lats and longs into 12 different places, and if you get a decimal point wrong, there are really serious implications. The choke points that we have right now are solvable, and algorithms will enhance it, but this is the first step that you have to do before it. The other piece is the swivel chair fix. So for us, it's the fact that data exists in ungodly number of places in the department at different classification levels. I know there are a lot of people in industry here, and I apologize, but this is not something you can fix. This is an us problem. We have to fix this, because what it feels like at moments is that we can build these exquisite, let's call them grocery stores, where we can build these tools and the infrastructure and the excitement of you will have the most incredible deli available, but if you haven't stocked it with the food and if you haven't done outreach to your suppliers to get it there, then you're just standing in an empty, very pretty grocery store. And sometimes it feels like we're standing in an empty grocery store. So for us, big lesson has been that we have to work on that data sharing, data integration, data fusion as a department in order to be able to leverage all of the wonderful tools that you are building as a community. So how exactly are we going about it as a combatant command? So we believe that capability sprints are the way. And we do this on a monthly basis. We have monthly sprints where every single month we get together and we see how our software tools are performing. We check the latency. We see how many targets we can move along. We upskill other folks who happen to have come into theater recently, because the turnover is extremely high and that alone is an adoption problem. And so we'll run every 30 days at our component level. We will work with our software tools, see if they actually meet our workflow needs, and start doing some preliminary testing with our algorithms. How did your computer vision perform? And we'll have analysts coming back and saying, not great. We were told that this was going to be really, really good at rocket launcher detection, but it turns out that the model wasn't fed with enough imagery from our specific theater. And so for that reason, it hasn't performed as well. But that's good feedback that we can then give and say, hey, NGA, owner of Maven, we actually need you to ingest more data that's specific to our region. And that, I think, is a really big takeaway that I think we've also learned, is that for algorithm performance, you have to be integrating live, real data. Simulated data can only get you so far. Real data is really where you're going to make your gains, because how would a computer vision algorithm know what a Dow in the Arabian Gulf looks like if it had never seen a Dow? How would it know what a UAS outside of the pattern of life flying outside of one of our bases looks like if it has never been watching the air around one of our bases to understand what normal looks like? So training on real data is where performance is going to come. We can set the stage by having our own organizations that are ready for this, and do not assume that you're going to be handing us the perfect solution. We understand that we're going to iterate, and we've created organizations that are explicitly focused on that. So Task Force 3.9 is the Army's tech adoption hub, Task Force 5.9 is the Navy's tech adoption hub, and Task Force 9.9 is the Air Force's tech adoption hub for our central command components. And so we are organized, have the entities that this is their full-time job, this is not a collateral, this is their mission that they are focused on. We have the mechanisms, which is these monthly sprints. We roll those up into quarterly sprints with the headquarters so that we're also testing the friction points of, can we pass data, can we see the same picture from a headquarters level? And we're increasingly integrating OSD and the Joint Staff, because CDAO has been kind enough to partner with us for our exercise series to see, again, the friction points of passing data and passing decisions up to that level for certain types of activities. We break this out into workflows. You will see that these are not perhaps what you would normally think about in industry as your workflows, but these are our workflows. And you can actually break them out and say, can I build a software tool that does your job a little bit easier, where all of the data will be in the same place? Can I take something that used to take you 3 hours and pull it down to 10 minutes? Can I take away the time that you were having to call 12 people to confirm that you're on the same page just by giving you the same tool, where you all be able to see the same point of interest, see when one of you made an update, at what time and why, with the notes that you've added? If so, gosh, shouldn't we try and do that? And then we will continue to run these sprints so that you have metrics, because we don't want to just do this once and say, oh, wow, that worked really well, and then step away from it. You can have a recurring moment in time where every deadline you look and say, how did this perform relative to last time? How many targets were we able to practice the muscle memory of passing? How well did the computer vision algorithm perform? Is our confidence level on this increasing, decreasing? Why? Is there a way that we can improve it by giving our own data over to the organizations that are developing these models? And so, again, we have a drumbeat of activity that forces us to be very precise about how our performance is. We have a drumbeat that forces us to be very precise about the workflows that matter most to us. And it then allows us to test. Again, we are shaking the trees to find the friction points. Do I have the data I need? Is it in the right classification level that I need? Do I need to knife fight another organization to ask for access, even though hypothetically DepSecDev said we're all supposed to share our own data, but sometimes we do, sometimes we don't? These are the types of fights that we're learning that we have to go through, and we'd rather do it now, because when the fighting starts elsewhere with strategic competitors, these are going to be really hard problems to work through. I would like to say that the problems we face when the shooting starts in the Pacific are going to be these high-tech issues. It's going to be much more low level than that, and you have to start working through them now. That is what we've learned. So again, the problems that we've learned are not specific to CENTCOM, right? Like broad maritime geography, confusing airspace to monitor is not an us problem. The Indo-Pacific has the same issue because there's a density problem. No matter how many assets you give them, that is a density issue. That is a massive geography to cover. The data fusion problem is not specific to CENTCOM. The fights that we're having to have inside the department to navigate data sharing is something that all of us are going to have to fight. And so what we would like to do as a headquarters is fight those battles, allow other combatant commands to continue doing their jobs, and then we can share the lessons learned over to them through the mechanisms that we've stood up. Our task forces are moving out on the hardware that will allow us to collect data better. We as a headquarters are working through the data friction points to feed the grocery store, essentially, of software tools and software suite that we think help us do our jobs. And then we are communicating with the other combatant commands to make sure that these tools aren't CENTCOM specific, that they really would apply to other folks. For some reason, I thought I had more than that, and apparently that's it. Thank you.